And yep, I am live. And by the way, those are dinosaurs in the background. Source? Dinosaurs in the background. Let me lock this. And I probably am live. Yep, I am. And let's just begin. And first of all, I will just, let's say, complete the question that we were doing yesterday. Not this errand of code 2015. Day two, yep. And we had done part one, and now today we will do part two, but not right now because solving questions is fun, and I want to solve a question when we get overwhelmed during studies, right? And there are a couple of things which I do not understand, and I would like to study them. First of all, pointers to functions, and then we will read about structures and input and output. So, yeah, pointers to functions, which is, I don't get it. What are pointers to functions? Well, functions are instructions which are stored at a particular location, and if you can share the pointer to them, that is cool. Or I can do something really amazing. Let me show you. Shit, option is not here right now. Let me hide my screen and I will show you this in a second. Uh, yes, yes, yes. Wait. Yep, it might be done. Yep, you can see a lot more of me if that was your goal. And yeah, that is cool, right? You can see my hands and everything, even down here. And you can see the dinosaurs in the background, which are like, of course, there have to be dinosaurs in the background. Tyrannosaurus, I don't know what its name is. I do not understand the geological time scale. Yeah, pointers to functions. We started at 350. Yeah, around 350. Okay. In C, a function itself is not a variable. Yeah, but it is possible to define pointers to functions which can be assigned, placed in arrays, passed to functions, returned by functions, and so on. We will illustrate this by modifying the sorting procedure written earlier in this chapter so that if the optional argu dash n is given, it will sort the input lines numerically instead of lexicographically. I'm already getting bored. A sort often consists of three parts: a comparison that determines the ordering of any pair of objects, an exchange that reverses their order. A sort often consists of three parts: a comparison that determines the ordering of any pair of objects. Yes, an exchange. I do not want to read about the things like that. Let me just go on to ChatGPT. I do not want to read about how things are done. Well, I only want to read about the C language, not other things like DSA. So in C, what are pointers to functions? And my theory is functions are just ins just set of instructions to which mm, a branch instruction sends the to which sets the program counter when that function is called, question mark. Yes, exactly. Function in C are just a set of instructions in memory, and calling a function is essentially modifying the program counter to jump to the function's address. A function pointer in C is a pointer that stores the memory address of a function, allowing you to call functions dynamically. What is a function pointer? A function pointer is a variable that holds the address of a function. That is the starting byte address of the function, just like a normal pointer holds the address of a variable. Basic syntax: return type, pointer, name, parameter types. Okay, like this. Integer is the return type, and this is the function name. This is the pointer's name, and then these are the inputs. It can point to any function that matches this signature. Example, and I can use the and sign to get the address. No, just equal to add. That would get the address of the function. Okay, and a result equal function pointer, and that put in the arguments, and I will get the result. I use function pointers. Dynamic function calls, you can choose which function to call at a runtime. At a runtime. Callbacks. Useful in event-driven programming. Useful in event-driven programming. Example, event-driven programming. Callbacks. Huh. Yeah. Single signal handlers, sorting functions like qsort. Reducing code duplication. Used in generic programming. Function pointers in arrays. Jump table. A function that prints hello and a function that prints by. Then this function that does not take anything. No, it is an array of functions which contains hello and by, and then I can just call them like that. That is crazy. Function pointers as arguments. Okay, here is a function called execute. Not a function, but wait, yes, here is a function called execute, which takes in a function pointer, and that function pointer points to a type of function which returns an integer and takes in two integers. And this function also takes in two integers x and y and calls that function on those two integers and returns the result. And here is a function multiply. The main function calls that with the multiply and those and does the thing. Okay, function pointers and type def. I type def this, then I can do operation. I can call operation instead of defining all of this. Yes, I can just call this operation, and yeah, type def. Okay, and anything else that I want to know? Seems like okay. Now, so yeah, I got this. Complicated declarations. Nah, I can just move on to structures. A structure is a collection of one or more variables, possibly of different types, grouped together under a single name for convenient handling. Uh-huh. Structures are called records in some languages, notably Pascal. Structures help to organize complicated data, particularly in large programs, because they permit a group of related variables to be treated as a unit instead of as a separate entity. And one more thing that I would like to understand: when I say int, star, pointer, and array, what will this pointer point to? And what I think is it will point to an I think that this pointer will contain the address for an integer array. The address for an integer array. Your intuition is close, but let's clarify it step by step. This declares an array of pointers. This is an array of pointers and not a pointer to an integer array. That makes sense because pointer to an integer array does not mean anything. It is just a pointer to an integer. Breaking it down, this is an array of pointers. Okay, makes more sense than my stupid monkey brain. One traditional example of a structure is the payroll record. An employee is described by a set of attributes such as name, address, and can you guys see my hand here? No, you can see it when I bring it up here. My face is too far away. Nope, that is okay. Traditional examples of structure is the payroll record. An employee is described by a set of attributes such as name, address, social security number, not here, salary, etc. Some of these in turn could be structures. A name has several components, as does an address and even a salary. Another example, more typical for C, comes from graphics. A point is a pair of coordinates. A rectangle is a pair of points. Rectangle is a pair of points. Yeah, is it? Yes, a point. Yeah, if I have 2 points, I can calculate where they meet. Yep, I only need two diagonal points of a rectangle and then I can figure out where the whole rectangle is. The main change made by the ANSI standard is to define structure assignment. Structures may be copied and assigned to, passed to functions, and returned by functions. This has been supported by most compilers for many years. But the properties are now precisely defined. Uh, Automatic structures and arrays may also be initialized. I can initialize automatic structures and arrays. That is crazy. Automatic means that they only exist during a function call and after that they just go away. Basics of structures. Let us create a few structures suitable for graphics. The basic object is a point which we will assume has an x coordinate and a y coordinate, both integers. X and y both are integers. Okay, and here is the structure definition. The two components can be placed in a structure declared like this: struct called point, which has these. The keyword struct introduces a structure declaration, which is a list of declarations enclosed in braces. An optional name called a structure tag may be used, may follow the word struct, as with point here. The name, the tag names this kind of a structure and can be used subsequently as a shorthand for the part of the declaration in braces. Okay, now a few things I want to understand that I can remove this. And when I define a structure in C like follows: struct point int x, 1 2 3 4 int y, mm, this gives me a data type which I can use to allocate memory on the stack on the .data section of the program, which adheres to this format. Yes, so what was my question? Nothing, it is just Yeah, yeah, just that. Just that. No question. You are partially correct. Defining a structure like this creates a user-defined data type, but how and where memory is allocated depends on how you declare variables of this type. Where is memory allocated for a structure? The location of the structure memory depends on how it is declared. Global or static variables are sent to this. Static variables or global. That is all the type of variables. These are global variables. Struct point p equals this and struct point p initialize. Mm-hmm. Yes, yes. And global static initialized variables go into the dot data section and uninitialized go into the dot bss section. And bss means block started by symbol. Local automatic variables stack foo is a function which declares a structure stored on the stack. Local or automatic variables are stored on the stack. Okay, local or automatic variables are stored on the stack. Local variables exist in the stack and are destroyed when the function returns. Okay, that makes more sense. Dynamic memory allocation heap. If I am using malloc or something like that, yep, I get it on the heap. Yeah. Okay, and one more thing, not reason. What is the difference between dynamic memory and data section? Um, what is the difference between dynamic memory and mm, static memory? I think that static memory is specified before the program sta- starts to execute, and when the program is loading a section of the memory is separated is cleared to store the static variables in the dot data section, but in dynamic memory until the line of code which asks for memory on the heap uh, isn't executed, no memory is allocated for it, right? Yes, your understanding is mostly correct. Let's break it down in detail. Static memory versus dynamic memory in C. Memory in a C program is divided into several sections. Code, yep, text segment stores compiled machine instructions. Data segment stores global and static variables. Stack stores function calls, local variables, automatic variables. Heap stores dynamically allocated memory. The major difference between static memory and dynamic memory lies in when and how memory is allocated. Static memory allocation allocated before allocated before program execution begins at load time. Yep, allocated before program execution begins at load time. Memory is assigned in data section for initialized variables or .bss for uninitialized variables. The size is fixed at compile time and cannot change during runtime. The size is fixed during compile time and cannot change during runtime. The size is fixed at compile time and cannot change during runtime. Yeah, the memory is automatically deallocated when the program terminates. Okay, and this is statically stored. This is statically stored, but I think this is stored on the stack. This because it is an automatic variable. Counter plus plus print the counter. Counter will be printed as one. Yep, and then I call foo, and then I call foo again. But the counter is not initialized for the second time. I get the same counter as before. Returns value across function calls. Retains value across function calls. Static variables inside function stored in data sections. Static variables inside functions are stored in data section. Static global variables is stored in data sections. Okay, and how is no reinitialization across calls if they are static. Dynamic memory allocation. Memory is allocated during runtime when malloc or calloc is executed. Memory is allocated on heap. The allocated memory remains available until explicitly freed. Using free allows for flexibility, resizing, creating objects dynamically. Example of dynamic memory allocation. This give me a pointer to an integer and give me size int. If pointer is equal to null, then print memory allocation failed, and then this print value of the pointer, which should be 42, value 42, and then free the pointer. Memory is allocated when malloc is called. If the program never reaches the malloc call, no memory is allocated. Free pointer is required to avoid memory leaks. Key differences between static and dynamic memory before execution: compile time at runtime. Okay, how does the okay mm, is l- um is it the job of the operating system to create the context for running the program, that is creating the static variables and creating the static variables and loading the program instructions? Guess it is. Yes, you are absolutely right. I like this one better. Yes, it is indeed the operating. Well, yes, it is indeed the operating system's job to set up the environment for your program to run. This process is known as program loading and execution, and it involves preparing the memory layout and creating the necessary context. Here is a breakdown of how the OS manages this. Why does the OS, what does the OS do during when you run a program? How the OS prepares to run a program? Program loading process. They have a box in front, and seems like this is more material than this. Memory layout of a C program. This is much better explanation. They also have that. They also have the example, and let's see which one is longer. Oh, the right one. Oh shit, they chose the left one. Shit. Program. How the OS prepares to run a program when you run a program like executing a compiled C program with /a.out. The OS performs several crucial tasks, loading the program into memory. The OS takes the executable file like a.out and loads its contents into memory. It sets up various memory segments, code, text, uh, segments, various memory segments. Code text segment contains the compiled machine instructions, your function and logic. Data segment split into dot data and pieces for uninitialized. Uninitialized data is stored in the dot pieces section, and dot data contains the initialized data. Then heap for dynamically allocated things, memory, and stack for function calls and local variables and automatic variables. The OS allocates the memory for global static variables in dot data section and initializes them if needed, and zeroes out uninitialized static variables. Zeroes out uninitialized static variables. Your structure point example works like this. I can do this. Should first value will be given to the first thing and second value will be given to the second thing. That is crazy. The OS sets up a virtual address space for the program. This often includes text segment, read only program instructions, data segment is static and global variables, heap, heap, setting up the program counter. Okay. That makes some sense. And is there something else that I want to know? No, that is fine. Dot data section, static memory, and dynamic memory. I really want to do advent of code, but let's do this first. The keyword struct introduces, yep, struct, and struct point refers to the point. The variable named, the variables named in a structure are called members. X and Y are members. A structure member or tag and an ordinary, that is non-member variable, can have the same name without conflict. Since they can always be distinguished by context. Furthermore, the same member names may occur in different structures, although as a matter of style, one would normally use the same names only for closely related objects. A struct declaration defines a type. The right braces that terminates the list of members may be followed by a list of variables just as for an object, basic object type. And let me do one thing. Let me should first of all let me get a charger. I have the charger right here. I will get it, and before that, now it's much better. And now let me get the charger. Yep, got it. It is charging. I hope. Yup. Hope. What do I mean by hope? There is no hope. OBS Siri, OBS. Shit, quite a few things are running right now. Hmm. And here we go. The variables named in a structure are called members. A structure member or tag and an ordinary, that is non-member variable, can have same name. A struct definition defines a type. The right braces that terminates the list of members may be followed by a list of variables just as for any basic type. That is, this X, Y, and Z will have the same type that is inside this struct. Is syntactically analogous to int XYZ in the sense that each statement declares X, Y, and Z to be variables of the name type and causes a space to be set aside for them. A struct declaration that is not followed by a list of variables. A struct declaration that is not followed by a list of variables reserves no storage. It merely describes a template or shape of a structure. If the declaration is tagged, however, it merely describes a template or okay, if the declaration is tagged, however, the tag can be used later in definitions of instances of the structure. For example, given the declaration of point above, struct point pt. Okay, if there is a label, then that label can be used later to define a variable which points to a similar structure. This defines a variable pt, which is a structure of type struct point. A structure can be initialized by following its definition with a list of initializers, each constant expression for the members. This an automatic structure may also be initialized by assigning or by calling a function that returns the structure of the right type. Oh, there is this structure point, okay, and struct max pt equals this. Okay, a structure can be initialized by following its definition with a list of initializers, each a constant expression for the members. This an automatic structure may also be initialized by assigning or by calling a function that returns a structure of the right type. Okay, a structure will be initialized if I initialize a structure like this, then a structure will be initialized which has the data type of a relevant structure. But what does this do? Like, do I get a new structure if I have not defined anything? What does this do? The line is hmm, seems invalid. Struct this is invalid syntax and will cause a compilation error. Let's analyze why. Yep, this is not declared when I am using a struct. That means I am declaring something, but then there is no tag name to identify the structure that I want to declare. And then there is the variable name. You must define a struct before you can create a variable of that type. The correct syntax would be this. But even this definition would still be invalid. I would have to do something like this. Yep, this correctly declares point as a variable of type struct maxpt. If maxpt was intended as a variable name, it should not have a struct. Yep, if you simply wanted a variable, not a structure type, this would also be incorrect because the struct must always be followed by a variable structure name, valid structure name. Yes. So this line is syntactically wrong. A member of a particular structure is referred to in an expression by a construction of the form structure name dot member. The structure member operator point connects the structure name and the member name to print the coordinates of the point pt. For instance, printf this points gives me the value of the variable x inside pt, and the value of variable y inside pt. Or to compute the distance from the origin to point, I would have to do double distance square root. I'm defining a double. Uh, Distance is a double and square root, which takes in a double, is also a double. And then I am defining, am I defining square root? What the heck does this mean? Distance equals square root of this whole thing. There seems to be, nope, there does not seem to be. I am type converting x into double, multiplying, taking its square plus Type converting y into double, taking its square and adding the both and finding the square root. But what the heck does this double square root mean? This also seems syntactically wrong. Isn't isn't double sqrt double wrong since it is if square root is a predefined function, and this is the prototype for the function, so therefore it is correct. If here I am trying to define the prototype for the square root function, then it is correct. The square root, the structures can be nested. One representation of a rectangle is a pair of points that denotes the diagonally opposite corners. Rectangle has 2 points inside it and has P1 and P2, which are points. The structure rectangle, I can do dot dot to find out the values of inner structures. The rectangle structure contains 2 point structures. If we declare screen as a struct rect screen, then screen dot pt1 dot x refers to the x coordinate of point 1, member of a screen. Yep. And structures and functions. The only legal operation on a structure are copying it or assigning to it a unit, taking its address with and accessing its members. Copy and assignment include passing arguments to functions and returning values from the functions as well. Okay, can I? Let me see. And yes, one more thing I want to ask ChatGPT. When I when I get dynamic memory using malloc, doesn't it get free after the program has finished running, even if I don't free it inside the program? It not freeing would only cause error if not freeing would only cause error during the execution of the program, right? Yes, you are mostly correct. Let's break it down clearly. Does malloc memory get freed after program ends? Yes, the operating system reclaims all memory allocated by your program when it terminates. The OS manages memory at a higher level, so when your program exits all dynamically allocated memory, malloc, alloc, realloc, is freed automatically by the OS. This is why you won't see permanent memory leaks across multiple runs of programs. What happens when you don't free in the memory? While OS doesn't clear up after termination, not freeing memory inside the program can still be problematic during execution. Yes, during execution. Scenario program finishes execution. The OS reclaims memory no longer issued. Long running programs, example servers and GUI apps. Memory usage keeps increasing, can cause performance issues or crashes. Frequent malloc calls without free memory fragmentation and inefficient memory use. Embedded systems, low memory environment, memory leaks can be critical since no OS is managing cleanup. That is no garbage collector. Well, C does not have a built-in garbage collector. What if I built a garbage collector for C? Why is not? People must have tried, I don't know. When should you worry about free? Short programs. If your program runs for a short time and then exits, you don't have to free since the OS will clean up. Long running programs, servers, loops, GUI apps, games, etc. Not freeing memory can cause a memory leak since the OS only reclaims memory after program exits. Embedded systems, no OS equals no automatic cleanup memory leaks and break the system. Example of a memory leak, give me a pointer while true, and that is what I was going to write. This memory is never freed and I keep asking for memory. This keeps allocating memory indefinitely and will eventually cause crash due to exhausting available memory. Correct way to free: take a pointer, use it, and then free it later. Summary: was not calling free matters if program running is running. Best practice always free. Okay, yes. And there must be an upper limit for individual programs to how much of the memory they can access. That is, even if memory is not freed and they keep using more and more memory more memory, then still before completely exhausting the physical memory, the program the OS must have a fail safe which stops the program before it starts to in it starts to take up too much of the memory and hinder the execution of other programs. Right? There must be a failsafe there. Yes, you are absolutely right. The operating system enforces memory limits per process to prevent a single program from consuming all system memory and crashing the system. Let's break down. Let me break down. And memory leak.c include stdio.h int main, and while one int ptr equals, this is how it is done, right? Int pointer and malloc size of int, and yeah, that's it. What? Why is this wrong? Call to undeclared library function. So which library does malloc belong to? Standard lib. Okay. Applying memory leak. Dot slash out. It keeps taking up the memory, and at some point it must end. Let me see. What the system? Oh, there is a system information app, right? Uh, and the utilities folder. Where is the utilities folder? Yep, here is a system monitor app somewhere, which I am too stupid. So, of course, activity monitor right at the top. And memory usage is increasing. It it is actually increasing. Dot slash out has used 10 GBs of memory, 11 GBs now, only on a single thread, and OBS is using 56 threads. This is crazy, okay? It has used 12 GBs of memory, even though I do not have 12 GBs. Mac has only 8 GBs of memory. And this program has somehow still used up 12 GBs, okay? And it does not seem to be slowing down. This is the program ID. I can kill it from right here. Uh, program ID. Okay, it is taking up quite a bit. Statistics. What is this? Executable path. Okay, here is the path to the executable. Here is the user who is running it. Z parent process is this which called it, I guess. Oh, in the real memory, it has only taken this much, but in the virtual memory, it has taken this much storage. 900 GBs. It has gone up to 17 GBs. Virtual memory, this is the total virtual memory size, which is even that is increasing. Shared memory, virtual memory size is increasing. Okay, and this is increasing 7.18. App memory, wired memory, compressed memory, the PID percent. What was the PID? 71934. Program ID. Sample. Please wait while the sample is being taken. Okay. What is this? Processing. Load address. This is the actual physical address from which I got the program. That is crazy that I can just see that. Code type is this. And I hope that I am not giving out any sensitive information by this. Let's just end the program and see the memory fall. Here, so it has all, no, it's gone. Virtual memory size went up to 1 TB. 1 TB, that is just crazy. I was allocating for space for integers, and that is just crazy. Yes, in a 64-bit memory limits on a program, each program has a upper limit on how much memory it can allocate. It can allocate if even if the system has free memory. This limit is enforced by process address space limit. Mhm. Process address space limit. In 64-bit system, a process typically has a virtual address space of 256. A virtual memory space, it has 256 terabytes of virtual memory. In a 32-bit system, a process is limited to 4 GB of addressable memory, 2 to 3 for users, rest for the kernel. Kernel is a bitch taking everything, but it can panic, so let it have it before it panics. However, just because a process can address this much memory doesn't mean it can use it. Yes, operating system memory management. The operating system, the OS, places limits on memory usage throughout several mechanisms. The OS places limits on memory usage throughout several mechanisms. Preprocessor memory limits. Linux uses ulimit to enforce a maximum memory limit per process. Windows enforces memory quotas via system settings and per user policies. Mac OS uses similar pre-process limits like Linux. You can check the memory limit on Linux, Mac OS using, okay, you limit it, unlimited. Shit. Stack size is this much kilobytes. This much kilobytes I can store. Processes, file descriptor, you limit S 8176. Isn't that too small? Um, stack leak, stack overflow dot c. How can I call stack overflow? stdio.h. How do I get memory? Keep asking for memory again and again. Recursive function which initializes a variable. Yeah. Um, int main, and this takes in, does not take in anything, but it calls in integer recursive which takes in an integer n, and what does it do? It initializes another number m which is equal to n plus 1, and then printf percent d 1 2 3 4 and m that, and then return m. But before that I would like you to call a recursive function with m, and go to the top, create a prototype, and then call recursive function with 0 clang stack, ah, clang stack overflow. Send the output to dot slash out, and let's see. I will see a lot of things. Stack did segmentation fault at this, and you limit s is 8176, and I got an error at this number. This is this many kilobytes. So if I multiply this by 1,000 kilobytes, but an integer takes up 1 byte. So let me change it up to not integer but a character, right? It takes in a character n, and returns a character n, and initializes a character m which is not equal to what. Let's see if n greater than a, if n equal to not a but z, then return a, else return n plus 1. Yo, and here print a character, call it with m, and cool. Yep, we are cool, and I expect to see good things. And yep, we got an error at 72382, segmentation fault. Okay, these are a lot of letters. You limit s, and what am I trying to see? I am trying to see what this number means. Should there are actually are a lot of letter characters here, right here, right, Last time it was 72582, and now it is 72832. Pretty similar, and 8000 kilobytes mean 8 MBs. Yeah, and yes, upper limit you can set an upper limit using this. Okay, yes. Now moving on, structures and functions. We did. Let us investigate structures by writing some functions to manipulate points and rectangles. To manipulate points and rectangles, there are at least three possible approaches. Pass components separately. Pass components separately. Pass an entire structure or pass a pointer to it. I can pass in the structure or I can pass in the pointer. If I pass in the structure, the function gets a copy of the structure or a pointer to it? Well, if it does get a pointer to it, then passing a pointer to it should not have been written as a different way to pass on the structure. Each has its good points and bad points. The first function make point will take two integers and return a point structure. This takes in two integers and returns a structure point, makes a temporary thing and then returns temp. Notice that there is no conflict between the argument name and the member with the same name. Indeed, the reuse of names stresses the relationship. Make point can now be used to initialize any structure dynamically or to provide structure arguments to a function. Like this equals make point init. Oh, here is the prototype. This is the prototype. Yes, this is the prototype and screen screen dot point one gets point 0 0 and point 2 gets point x max and y max. Middle equals make point with this value. Okay. The next step is a set of functions to do arithmetics on point. A set of functions to do arithmetics on point. Add a point takes in 2 points and then returns a point. This p.1 and p1 p2 adds this and this and does this. Here both the arguments add. Okay, when I pass in a point, when I pass in a structure to a function, function is it passed by value or by, is it passed by value or by reference? It is passed by value. This means a copy of the structure is made. The function does not modify the original structure outside the function. The function does not modify the original structure outside the function. The function does not modify the structure outside the function. Okay. So if I do make a this, and this function takes in a structure point and makes them 110, and if I declare a pointer like this and then if I modify and print it, I would see the original values, not the updated values, because the structure was passed in by value, not by memory. That is cool. You will know Harari. That is cool. Here about the arguments return the structures. That is cool. I understand a bit of structures. Arrays of structures. I can declare arrays which point to structures, and now I feel like I should actually be doing advent of code, which is actually fun. Advent of code 2015 version. Question number no, not this. Question number 2's second part. This is going to be fun. Let me open. The elves are now also running low on ribbon. Ribbon is all the same width, so they only have to worry about the length they need to order, okay, which they would again like to be exact. The ribbon required to wrap a present is the shortest distance around its sides. The ribbon required to wrap a present is the shortest distance around its sides or the smallest parameter of any face. The smallest parameter around any face. Each present also requires a bow made out of ribbon as well. The feet of the ribbon for required for the perfect bow is equal to the cubic feet of the volume of the present. Cubic feet, cubic feet. A ribbon is also in cubes. A ribbon has to be in length, right? Mm, the feet of ribbon required for perfect bow is equal to the cubic feet of volume of the present. Okay, I need to find the volume, and that numerical value is equal to the length in feet of the ribbon that is required to make the feet of ribbon of the bow. Don't ask how they tie the bow, though they will never tell. For example, a present whose dimensions are this requires the shortest side is 2 by 3 and its parameter would be equal to 2 plus 2 plus 3 plus 3, that is, yes, 2 plus 2 plus 3 plus 3 ribbon of feet to wrap the present, plus 2 into 3 into 4, which is the volume, equal to 24 feet of ribbon. Therefore 10 plus 24, 34 feet. Okay, how many total feet of ribbon is required? Let's go to the AOC folder and into date 2 and part 2.c. Nope, part 2.c. Include stdio.h int main. This does not take anything, and yes, now a file pointer, and this is file pointer, and this will I will call fopen, which takes in which will return fptr, or I can do this right here, equals fopen, first the name of the file, which is text.txt, and then r, that is, I want to open the file in the read mode, and then I want to find out the length, which would be, first of all, fseek in the fptr see the length, seek end, right? uh, After seeking the end, do int length equals f tell file pointer fptr, right? And then and f re or just rewind the file pointer to the start, and then get some buffer equals char star malloc, what is how much size, length plus 1, and then f read with the void pointer buffer 1, and this is going to be equal to length, and this is going to be equal to fptr. After reading the file into the buffer, I can free the buffer and then fread fclose. There is no nothing as f. There is fclose, right? fptr fclose it. Now I will give that to a function which will find the ribbon length. This function will find the ribbon length. Return an integer, find a ribbon length. It will take in a character pointer s and then do its stuff. Return 0 at the end. And yes, yesterday I implemented this same code, but now today I want to do it twice. I want to do it again, and not this. V split text.txt and move it to the right, and move it to the right like that. A little bit more would be happy. Yep. And now, yep, I will also take in the length. Should I? Nope, I won't. While no, I would like to store. Yeah, I will also take in the length. Int length and char line 50 character long. Yes, and int index will start at 0, and for loop for int I equals 0, I less than len I plus plus. Do something like this, which is if si not equal to new line, then if it is not equal to new line, then simply do line index plus plus equals si. Cool. And else, if it is not, then I know that I have a line, a complete whole line in the line character array. Now I want to find out length, breadth, and height. So integer length, breadth, height, and length equals breadth equals height equals 0. Yo, yep. And now I will do for int j equals 0, j less than index j plus plus. I will loop through that line and find out length, breadth, and height. Before that, int state equals 0. Now, if line j equals x, then simply do state plus plus, else do a switch on state. Do a switch on state. How? Case 0. When state is 0, then I will treat it as length. Then length equals length length into 10 plus something. What is that something? That something is line j minus 0, because I want to get the value of line break. Is that correct? Will this increase the length? Give me the length. Yes, this will give me the length. And then case 1, length breadth equals breadth into 10 plus breadth j minus 0, and then simply break after it. And then case 2, which is also crazy, going to be for height into 10 plus breadth, no, line j minus 0 to get the numerical value of that thing. And breadth is not line, this has to be line. Yep. And yeah, what after that? This will do it, right? Is there something that I have to do after every switch statement? Nope. Nope, nope, nope. Or after every loop. Or after every character, going through every character in the loop. Nope. What I have to do is now after the loop. Now at this point, after the loop has ran, I successfully have length, breadth, and height. Now, integer wrapping ribbon equals uh, the shortest thing. Fuck. I need a wrapping ribbon and bow ribbon. Bow ribbon is simple. It is just equal to length into breadth into height. But wrapping ribbon, I have to calculate some things. Find out if length greater than height, then I know that height is smaller. Uh, if I do if length, I have to find out the smallest parameter, right? Yes. For that, I will simply have to find out smallest two sides. Length is greater than breadth, then I know that breadth and height are the smallest ones. Therefore, a wrapping ribbon equals height and breadth. 2 into height plus breadth, right? And else, 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 wrapping ribbon equals 2 into, I know that breadth is the smallest, is the largest at this point. Therefore, height plus length, length, right? And I think I can remove these. Oh, I know. Yep, I cannot. Right. And after this, I have a different else. If at this point I know that height is greater, so let me compare with height. If breadth is smaller than height, and height is also larger than both breadth and length, then I know the wrapping ribbon will be equal to the parameter which encompasses the length and breadth. But if it is otherwise, then I know that wrapping ribbon, that height, that breadth is the largest, and thus height plus length, height plus length, height plus length. I have everything I wanted, right? Let me declare a variable up there which is int final, sorry, which starts at 0, or maybe just total ribbon, and here down below I have, after finding it out, I can do total ribbon plus equals bow ribbon plus wrapping ribbon, right? That is cool. And anything else? Yes, anything else. Index equals 0. Anything else? Nope. Just return total ribbon at the end. Yeah, that seems like correct. That seems pretty cool. I can just paste it here like that. Yep. And just call the function find ribbon length on buffer and length. Yeah, this will give me integer total ribbon equals this, and then I will just print it total ribbon percent %d new line total ribbon. This should work. Clang part2.c dot out. Okay, dot slash out. Total ribbon is 3842356. 3842356. That's correct. That is correct. Yo, Technoblade never dies. Okay. Now I want to push this up to Git, but I do not want the out files to go up there, right? Dot out files, the executables. So I can create n dot git ignore. Yes, git ignore, git ignore, n dot git ignore, and this will contain. How do I tell it that I want to remove every file that has dot out? Is that the correct syntax? Let me do how to exclude dot out files in C git ignore. Git add dot git ignore to exclude dot out files, and this is it. Is that add an exception rule dot ignore files dot out files in C project using git ignore. Create a git ignore file. If you don't already have one, create a new file named dot git ignore in the root directory of your git repository. Add the exclusion rule. Open the git ignore file and add the following line. This tells git to ignore all the dot out extension. No, this is not a dot out. Git status git add everything, git commit message completed day 2 git push, and let's see, did that got to my GitHub? No. Pro coders do it like this. Add-on of code. I will see it. Shit, but I have to do ./git.com jatin Raghav and slash add-on of code. Yep, motherfucker, I got it. And in this branch, do I have the git ign? I still have it here. That is embarrassing. And I also wanted to know, is this the fastest way that I can do this? Well, my code can I can code 55% faster, but I do not want speed at the cost of quality and at the cost of learning. And that is the motto we live by, or at least try to. What if that would actually be crazy? What if we did went till up to till day 25? That would be unbelievable. If I went till day 25, that would actually be crazy. Literally. I would be very happy if I went till day 25 without having any formal or informal education about DSA. Well, I know a little some things like Tower of Hanoi. I'm trying to solve it on my own somehow if I can, but I know much more about programming in general after learning assembly code, assembly language than I did the times when I was trying to do this before. And this year I plan to do it every day. That would be crazy. Shit, how long has it? It's been 1 hour 20 minutes now. What is all this? This is under arrays of structures, which is okay. Okay. Pointers to structures. I can find pointers to structures, and I can pass pointers. Self-referential structures, structures which point to themselves. That is also okay. And then table lookups. I can create tables inside structures by making self-referential structures, and I can do type def. I can find unions is something that I do not know about. Do I want to read it or just move on to doing crazy some crazy this code add-on of code, which is a which just happens to be a tree, a crazy looking beautiful tree. Ah, okay. A union is a variable that may hold at different times objects of different types and sizes, while the compiler keeping track of size and alignment requirements. With the compiler, okay, um, okay, I have a question that does the operating system has to know, but now know to which to from which language an executable binary was created when running it, or it doesn't make any difference if it if the binary was created was compiled from Rust or C. I think it does not make any difference. No, the operating system does not need to know. Yep, which programming language was used to create an executable binary. Once a program is compiled into binary, it is just a set of machine instructions, and the OS loads and executes regardless of whether it was written in C, Rust, Go, Python. Python can be compiled. Yep, there are Python compilers and C interpreters out there. Crazy world. Why doesn't the OS care about the source language? When you compile, yeah, why would it? Why would it care? And yes, one more thing. When not freeing memory, why is it called memory leak? As if someone else was able to access our data. The term memory leak doesn't mean that someone else can access your data. Instead, it refers to the memory that is allocated but never freed, leading to a gradual increase in memory usage until the program runs out of memory. Why is it called a leak? The term leak is a metaphor similar to water leak. How memory is leaking out. Imagine a bucket of water, your available memory. If you keep pouring water in, allocating memory, but never emptying it, freeing memory, the water level keeps rising. If Imagine a bucket of water, your available memory, a bucket of water. I already have water. If you keep pouring water in, allocating memory, but never emptying it, freeing, the water keeps rising. Eventually, the bucket overflows, your program crashes, or the system slows down. The water is still there, but it's wasted because you can't use it anymore. Similarly, in a memory leak, the OS still knows the memory belongs to your program, but your program does loses track of it. It no longer has a pointer to free it. It no longer has a pointer to free it. Yeah, yep. It no longer has a pointer to free it. Yep. But the OS thinks that my program is using the memory, but I do not have a pointer to access the memory. Oh, so what that would mean, I guess, is when I malloc, my function makes us a call which asks the operating system to get some memory. And when I free it, it tells the operating system, hey, I have completed my use of this memory. You can give it to someone else. If your program terminates, the OS automatically reclaims all allocated memory. No system-wide harm, no real leak after the program exits. But if your program runs for a long time, like a server or a game, it keeps consuming more memory. The OS won't free it until the program exits. Eventually, the program or even the entire system might run out of memory. Examples of memory leak. This program keeps allocating memory. Leak, create a pointer, a big pointer, which points to 100 integers, 100 nibbles, 50 bytes of storage. For short-lived program, no big deal. For long-running program, there is a big deal. How to prevent a memory leak? Free the pointer, goddammit. Use tools like valgrind, which check if there are any memory leak. Valgrind wasn't Valgrind also discussed in CSFT? I guess it was. Use smart pointers if you are using C++. TLDR too long didn't read. Okay, now, well, I read the whole thing, but I'm not reading the TLDR ironic. Okay, okay. Hmm. So when I allocate memory on the heap, my code makes a syscall and asks the OS for some memory, and the OS returns a pointer to it. And afterwards, uh, when when I when I free the memory, the code makes uh, sys makes another This is called this is called to the OS and tells it that I have completed using this memory and thus remove it from my label and from remove it from from this program's space, and that memory can then be used by other programs since now it is marked as free to be taken and is not under another program's use. Yes, you have got the right idea. Here is a more detailed breakdown of what happens when you allocate and free memory. Is anyone watching the stream? I wonder. I wonder how free to be. Why? Yesterday was blue sky to see. That is not HD. Oh, that is not 4K. But that is fine. At least I have the dinosaurs behind me, which is cool. What happens when you allocate memory? Malloc. Your program calls malloc, which requests memory from heap. Yep. The C runtime, glibc or another standard library handles small allocations by managing a heap region. If the request is larger, if the memory that I need is smaller, then a standard library itself manages a heap section, and I can use that heap section. But if the request is large, C runtime. If the request is large or more memory is needed, malloc internally makes a system call to the OS. On Linux, brick on Windows, virtual alloc or adjustment or mmap for large allocations. The OS finds a free region of memory, marks it as reserved for your programs, and returns the pointer to that memory. Example this. Now, PTR holds the address allocated to memory in your program's heap. What happens when you free? Your program calls free pointer, which tells C runtime that this memory is no longer needed. That this memory is no longer needed. That this memory is no longer needed. The C runtime does not always immediately return memory to the OS. Does not always immediately return memory to the OS. It may keep it in an internal loop for the future malloc calls. For the performance reason, if the block is large, it may use movemap Linux or this to return memory to the OS. Okay, it just returns memory to the OS. Now, do I want to do this? Yes, I want to do this, but before that, let me first read about unions. And then there are bit files, and that is it for this chapter. And after that, I will do advent of code. After reading about unions and bit files. Okay. A union is a variable that may hold at different times objects of different types and sizes, with the compiler keeping track of size and alignment requirements. Unions provide a way to manipulate different kinds of data in a single area of storage, to manipulate different kinds of area in a single unit of storage without embedding any machine-dependent information in the program. Without embedding any machine-dependent information in the program, they are analogous to various records in Pascal. Don't know Pascal. As an example, such as might be found in a compiler symbol table manager. Suppose that constant may be an int, a float, or a character pointer. Int, float, character pointer. As an example, such as might be found in a compiler symbol table manager. Suppose that constant may be an int, float, or character pointer. The value of a particular constant must be stored in a variable of the proper type. Yet it is most convenient for the table manager if the value occupies the same amount of storage and is stored in the same place regardless of its type. Okay, this is the purpose of a union, a single variable that can legitimately hold any of the several types. The syntax is based on structures like this. Okay, I can use a union to define a variable which can hold multiple data types in the same memory location. That is crazy. The variable u will be large enough to hold the largest of the three, which in this case is a pointer. Pointers are, well, seems like they are all 32 bits. That is fine. The specific size is implementation dependent. Any of these types may be assigned to you and then used in expressions so long as the usage is consistent. The type retrieved must be the type most recently stored. It is the programmer's responsibility to keep track of which type is currently stored in a union. The results are implementation dependent if something is stored as one type and extracted as another. Okay. Syntactically, members of a union are accessed as this or a pointer, union pointer, and then this notation or a dot notation with the name, union name. Just as for structures, if the variable u type is used to keep track of the current type stored in u, then one might see code such as this. If I have created a variable u type which create tells me the type of u, then I can do this. Okay, bad type unions may occur within structures and arrays and vice versa. Okay, okay, a union may be initialized. Okay, the storage elevator in chapter 8 shows how a union can be used to force a variable to align a particular value, and a union can come inside a structure like this. Here I have a union called u, which stores in these, and then I have sim table. Sim table is shit fucking hell goes to the ith structure in the sim table array and goes to its u element and gets its ival. This ival. Okay, the first character of the string is will be either go to ith and this. Ah, yeah, yeah. Go to this location and find whatever is there. Then 6.969. When storage space is at a premium, it may be necessary to pack several objects into a single machine word. To pack several objects into a single machine word. One common use is a set of single bit flags in applications like compiler symbol tables externally imposed data formats such as interfaces to hardware devices also often require the ability to get at pieces of a word. What the fuck is happening? When bit fields, let me ask ChatGPT. Uh, see, reason. I want you to reason. Reasoning, reasoning. Explaining bit fields and see bit fields and see this reasoned for 8 seconds. In C, bit fields are a way to specify that a structure member should occupy a specific bits number of bits rather than full size of its type. Ah, unsigned integer occupies 1 bit. This occupies and counter occupies 6 bits. This is memory efficient and easy. I can tell just how many bits I want this variable to hold. Reason. And now we can consider that chapter completed and move on to day 3 of Advent of Code. Day 3 CD days. Ah, CD day 3. No, CD day 3 and part1.c. We split text.txt. Yo, technically, Santa is delivering presents to an infinite two-dimensional grid of houses. To an infinite two-dimensional grid of houses. He begins by delivering a present to the house at his starting location. Infinite two-dimensional grid of houses. Okay, infinite two-dimensional grid of houses. He begins by delivering a present to the house at his starting location. Okay, and then an elf at the North Pole calls him via radio and tells him where to move next. Moves are always exactly one house to north, south, east, or west. Okay. After each move, he delivers another present to the house at his new location. However, the elf back at the North Pole has a little too much eggnog, and so his directions are a little off, and Santa ends up visiting some houses more than once. How many houses received at least one present? How many houses received at least one present? Okay, for example, this delivers. Okay, and this one. Control A, Control C, copy and paste it here. Right. Yeah. Let me first to make this go to the right a bit. This much is happy. Include stdio dot h and int main. First of all, I want to read the file. For that, I need a file pointer. File pointer fp file equals f open, which has text.txt, points to text.txt, and open it in read mode. And then I want to see the length. For that, I will do f seek in the f file. Go to one. I want to understand what this one represents. I will after this. if I remember. I might not. Seek end right and integer length equals f tell for p file and then rewind p file. Right now I have the length and now I can make a character buffer using malloc, like length plus one, right, right, and in the end I will free. I have to read the file after doing that. F read given the buffer, then one, then length, and then the file pointer p file file, and in the free put buffer and f close p file. Now let me create a function which gives me an integer, give unique houses. It takes in a char pointer s and does its magic. I will be needing a structure for this, an array of structures. I would be needing a place where I can store the houses that I have went to. For that, I will be needing a structure. I just read about the structures. Do type def struct point. I was actually reading about point. So this is just crazy coincidence. Write this and let me just randomly return 0. And then I would do array of point. The name would be point. Point array. How many houses long? I have to have an estimate of the houses before running the program. That does not seem right. Do I have? Yes, I do have to remember the location of every house that I reach. So of every house that I visit, so that I can see if the current house belongs to that set, right? And where will I store them? In an array. The houses, I can store them in an array. But if I'm going to take an array, then I need to define how many elements I want in that array. And that is crazy. Or what I can do is declare an array, right? Instead of declaring a very long, I would have to declare a very long array. I want to have the places of every house that I visit at one point in one array so that I can refer to it and check. Let's just go with 10,000, but this does not feel right in my bones. and do air 0 equals 0, expected expression. What do you mean expected expression? Uh, this is the way to define it, right? I just read that in the book. Structures and definitions to define a structure and also declare it at the same point. I can do. Oh, let me do this instead. Do x equals 0 and 0 dot y equals 0. Okay, I will also create a function which will take in that array and return as visited, and it will take in a point does not exist in here. So let me say that this is a global thing like that, like global. This will take in a point p and then point array. Maybe also the array length, which I can define as a global variable here. Max length 10,000. For int I equals 0, I less than max length I plus plus. If p dot x equals air I dot x and p dot y equals air I dot y, then return 1, else at the end return 0. Right. What else? I will also take in the length. No, thank you. Integer length, not a while loop, a for loop. For int I equals 0, I less than length I plus plus. What do I want to do? I have every single character. I also want to create a current point. Point current equals 0, 0, 0. That is where it starts. That is where it all started. Yep. Now I have to create a switch statement, or yeah, I want to create a switch statement. Yeah, no, yep. And then I will update the house. First I have to check. Okay, int direction, not an int, but this is going to be a point. Point direction equals nothing. And switch. What is the expression? Expression is s. I, and case is case for this means direction dot x equals -1 and direction dot y equals 0, right? Yes, right. And also break, then case right would mean direction dot x equals 1 and direction dot y equals 0. Yep, and also break, and then case if I go above would mean direction dot x equals 0 and direction dot y equals 1, and also break, and then case. How do I type the down symbol? Is it just V? Don't think so. Seems like it. Yep, it seems pretty much like a V. Let me compare these two. Yeah, it is a V. Shit. Then direction dot x equals 0 and direction dot y equals -1, and then I will just normally come out without the need of break. Okay, now I have the direction that I want to move. Now point new equal, wait, instead of giving it a point, it would be much better if I just give it x and y, x comma y, which are integers both, and instead of doing this and this would be much better. Mm-hmm. I have to define the prototype for that function, and then here 42 I can do has visited, which takes in an integer x. X would be equal to current dot x plus direction dot x, and y would be equal to current dot y plus direction dot y, and point array would be equal to array does not seem like a good name. Let me change that. Instead of array, I want to call it memory. It sounds very much elegant. Or memo sounds even more elegant. Memo as in dynamic memory. I will give it memo, right? If this is true, that is, if I have already visited it, then I do not want anything. I do not want anything to do with you. But if it has not visited, then I want to, yes, I also want to store the current address index for this. Index equals 0, int index equals 0, and here I'll do index, and in y index plus plus. Yep, 26. And if I have not already visited, Then I will add it to memo. How memo index equals current dot x, or maybe first let me update current dot x plus equals direction dot x and current dot y plus equals direction dot y. Why am I not getting auto indentation? That is fucking current dot x and memo index plus plus equals current dot y. Why is this? Oh, index x is this and y is this. I have updated the current location, the memo, and that. Do I have to update it? Yes, I have to. And at some point, I will also be calculating integer unique visits starts at 0 and 26. It will go unique visits plus plus, and at the end, return unique visits. Is this over? I feel like I have messed up somewhere and it will shine forth at the time of execution and give uniqueness. And first one will be buffer and the second one will be length. Integer unique visits equals this, and then printf unique visits percent d new line and unique visits. I feel like I have messed up somewhere. I actually feel like that clang part1 put the output to dot slash out. Okay, it did compile at least. Well, it took some time to compile because I guess of 189. That was pretty goddamn fast. Let's see. 189. That is wrong. Right? Wrong, wrong, wrong. You're not right, of course. Your answer is too low. If you are stuck, make sure you are using the full input data. There are also some general tips on the about page, or you can ask for hints on the subreddit. I put in 129. 189. Is it because I am starting unique visits at 1? I should start it at 2. Yes, no, I started at 1 because the place that I start is also a house that I have visited. 190, which might be it. 190. Answer is too low. Okay, let me check for this. What is the answer for this? Instead of passing the buffer, I will pass in my array, which is this. This, this, this. Not slash out. Uh, uh, did I save the program? Yes, I did. Did I clang it? Yes, I have now. Uh, 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 uh. Yeah, there seems to be some problem there. Answer for this is this, because the length is goddamn massive. Length of the string is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me pass it 10. This should not happen. Not chapter 9, part 1. Alright, I am declaring a point right here. If has visited returns 1, I will get 0. 8. If have not visited means if the output was 0, when will the output be 0? Current direction plus yes, and I am also updating the current direction every time, yes, and I am updating the memo to have the new thing at the new index, yes, yes, yes. This should work. How many times am I getting here? Printf %d, comma %d, and new line, and let me get the current dot x and current dot y for this. Okay, I keep going down, down, and down, and what did I, 1, 1, 2, 3, 4, and 5, and I got 6. Line part 1. Why does it keep going down? Left, right, up, down. Okay. Why do I keep going down? And why is has visited returning true? Is the up arrow not being conceived? Conceived, yes. Printf. Direction is %c new line, and it is si clang or slash out. Okay, when it is that, I do this, but when it shows me down, I don't do anything. When it shows me down, I go down. But when it shows me up, I'm not going up. I have copied this character, and if I place it here, then yep. Direction is this thing. This is not direction. This is symbol. For this symbol, what is the direction? For this symbol, direction is %d, comma %d, and what are these %d's? These are direction.x and direction dot y dot slash out. Okay, now let me do new line here dot slash out. Now when this is this, I get this 0 1 1 0 1. Okay, and when direction is similar this, I get direction this. Okay, I'm getting the correct direction, but seems like the function is not working. The compare function is not working properly. I am giving it current x plus direction x and current y plus direction y. If that is already there, then this returns me 1, and if it is not, then it returns me 0. It can also take an additional input, which is length, the index, right? And here it can say that it takes an int length, and also in the prototype, let it say the same thing, has visited int length, right? And it will not go till max length, it will go till length. And printf x, which is shit, I want to print the pointer array. Can I do that? Let me just print the new x and y. New location will be %d and %d, which is x comma y, and also new line, that is cool. Now clang and run. Okay, for this new, I got the new location as this, for which I got this. For minus, that is below, I got this as new location, and for this I got this. These are all messing up. Part-1, let's see. This represents that location updated, and this will print 2 new lines. Dot slash out, and let's see. Yep, in the first iteration I got the symbol this, and I had to move in this direction. Then new location was this, and location got updated to 0 0. Okay, and then I got the symbol this, direction was this, new location was this, the location that was given to the compare function. No, let me also do some more changes to print the things correctly. New location, location given to has visited, and not new location but current location. Copy this, and here print updated location, and remove one new line. print this after this. Okay, and here is symbol and direction for that symbol. This should work. Not work, but at least help me debug. For this, I got this direction, and location given to has visited was this, which is correct. So location became from this to this. Okay. For this, I got this direction. Location given to this was this. Okay, which was already visited. So that did good. Location given to has visited was 01, was 02. Why was it 02? Oh, even if, yeah, that makes sense. Even if there is a location even if I have visited that location, I have to update the current pointer anyway. If I have not visited the location, then I will add it to the memory and increase the unique visits. But if not, then I will simply increase the current location, updated location part. Answer is still 6. Fuck. Updated location has been reset to 0 if this is this. Then current location updated to 0, 01. When I did this, at this point I added this. Therefore, I should not have 01 should have been in the memory part. But it was not there. Okay, that is the problem. The memory array is not getting updated. Why is the memory array not getting updated? Let me do. Oh, it is. It might actually is. No, but it is not. Or is it? Less than. You can go less than equal to length and then see. It is still 6. Okay. So now the problem lies in that memory is not getting updated. Okay, let me write a function which prints the memory. After every iteration, I will print the memory, which is return void and print memory. It will take in a pointer and do this, and also take in the length, which is an integer. Now for int I equals 0, I plus plus, I less than length I plus plus, and yeah, printf. Well, before it, printf this opening braces, yep, and here printf this and %d comma %d, yeah, and new line, yeah, and s bracket I dot x comma s bracket I dot y, yep, and at the end printf closing bracket. No, at least call the function. After every iteration, let me not remove but comment out all the other lines. Comment. Okay, and here after every iteration, I will call the print. Oh, it has not been defined up there in the big place. Print memo, which takes in our memo thingy and gives us index, and also the index and just prints the memory. Okay, that is messed up. Let me do so I can see the boundaries more clearly. And yes, okay, after the it just does not get updated. It is not getting updated. Is it the value? Of course it is not. Fucking hell. Of course it is not getting updated. Now it should work. It does work. It does work. It does work. It does work now. 2. Now for the original output input. Uh, now that is that clang and then run it, and that is an unexpected consequence. Okay, the print part is taking time. I can just stop calling the memo function. 2567. 2567. Your answer is too high. If you are stuck, no, I'm not stuck. I got this. I got this. This is just the third day for advent of code, and my answer seemed shit. My camera went off. Shit. I don't know how long ago. That is just embarrassing. Let me check some things. Shit, you guys have only been seeing dinosaurs this whole time. At least I guess that is better. Seeing dinosaurs compares to seeing nothing. I don't know why the heck this happens. Ah, shit. Let me just use my laptop's camera for this. In that case, shit, the screen is stuck in this. Okay, video capture device. Yep. Use my FaceTime camera, which is this, but it is like rotated up. Ah, shit. It has to be rotated, transform, rotate 180 degrees. Yep. Put it down there. Wait, do you see my right hand on the right? Which should not happen. You should see. Let me flip it. Transform. Flip horizontally. Yes, that is more correct for you. and also add the screen capture. Capture screen. Yep, if that is correct. And let me transform fit to screen. Yep, yep, yep. That is okay. You see the dinosaurs and everything. That is cool. Mm. Okay. I got this. I got this. For this, what am I getting for this? Part 1 of C. When the length here is, I don't know, 4. It will go up to, and so let me change 4 to 5. Clang it and /print. Answer is 5. It should be 4, not 5. Let me print. It is taking some time to open. Updated locations, print memo. I want to print memo at the end of every loop. That is here. Print memo with memo and index. Clang, compile and run. Okay, it is 0 0 at the start, and then it goes up, therefore it becomes 0 1, and then it goes right, so it should become 1 1. Yep. And then it goes down, therefore it should become 1 0. And yes, I do have 1 0. Then it goes to the left, it should come to the start. Yep. But then there is one more move which is not here, so default is seems to be in the length correct part. Wait, the loop, I got -1. -1 and 0. That is, I got a downward facing arrow at the end. Why did I got a downward facing arrow at the end? And why? How many times did the loop ran? Loop ran 1, 2, 3, 4, 5 times, starting from the. Oh, wait, so I only have to give the length, correct length. Length is 4. It will start from 3 and go up to 2. Yes, that is correct. I'm getting a right answer for this, right answer for this, and right answer for this. Why am I not getting right answer for that? Why? Okay, instead of taking it up till the character, I will do since s I is not equal to e of f. Do I have a file at the end? Conflicting. Okay, let give unique house numbers. Remove 4. Will this work on that simple input? No. Okay. Line 31. 31 this. It is taking longer to compile now, and seems like I messed up. while si is not equal to end of file. I should see end of file in si. Okay, let me pass in the exact length of that. Let me find out if how that runs. The what is the index of the cursor position in a file pointer in C? Does it start at 0 and at the end, and when the pointer is at the end gives the length of the file? Yes, in C the file cursor offset starts at 0 and increases as you read and write. Understand F till and cursor position when you open a file doing this, and when you seek, if you seek end of the file and call F till, it will return the length of the file in bytes. That is what I want, in bytes. Let me add back the length part. When it is 4, I am getting the correct answer. For buffer, let me pass in length. Length will give me the length of the array. Battery is about to be full, and I am unable to solve the question. But I will wait. Of course, I will. Read f+1 characters. Ah, shit. Was that the problem? Did I pass in length? Think I not. It is taking much longer to open the file. Yes, I passed in length. Let me stop printing it. Clang and run. And 256, isn't that what I submitted last time? How can I check? By going back? Nope. 2567. Is that the same answer that I passed in last time? 2567. I have to wait 5 minutes. Shit. That is not the right answer. If you are stuck, make sure. Okay. Because you have guessed incorrectly 4 times on this puzzle, please wait 5 minutes. 2567 is not the right answer. Okay, 2567 is not the right answer. I will keep this here. I don't even know if it is higher or lower than the actual answer. Let me do up, down, down, up, down, and then I should be at the starting position. Side, back, side, back, side, back. I should be at the starting position, and then side, up, right, down. And what is the length of this thing? Length is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16. And what the answer should be? Answer should be 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 6. The answer should be 6. Should be fine. Answer is 5. Answer is 5. Let me print the array. Not slash out. Okay. The answer is 5. Why? What? Which one am I missing? 0, 0, right? And then I go up. This one is for up, 1 up. This one is for 1 right. That is also good. This one is for 1 left. Did I not go down? I think I did not go down. And this one is for 1 left and 1 up. Yep, I think I did not go down. At this point, I am at base position. Let me here go down and then up and increase this to 18. I should now get the answer 6, which is correct. So it is working for these, but not for the buffer. Why? Is it because of the length? Length plus 1, maybe? I don't know. I do have the correct length, right? Can I also? Yes, I can. I want to print the buffer itself. Here I got the buffer console.log %s, that is, it is a string, and print the pure string and given buffer, not console, of course, not console.log, printf, but buffer does not have end character at the end. So let me do, just read the length and let me do buffer length equals \null. I think this might be very wrong. Okay, 2, 5, 6, 8. This is longer than the last one. Okay, and in the end, I have this pattern: cat text.tx, cat text.tx, and in the end, that is the correct pattern. This might be it. 2, 5, 6, 8. If I'm not fooling around, this might be it. I have to wait 20 seconds. Okay. Am I actually sure that 2, 5, 6, 8 is the correct answer? Because if I'm not, then I am messed up. Then I will get a messed up answer. Wait, let me print the last character, these, so that I will know if I am getting towards the last parts of this file. And this is just part 1. The thing is that, yep, this is part 1. I'm going from length I equals 0, from length I equals less than equal to length, and let me read a bit. If I do end, seek end, move cursor to the end of the file. Okay, and long file size equals this, tell me, and yes, rewind, move it to the start. I can print file size. Okay. And when I'm reading and reading length, I am getting the length. That is also cool. That is also cool. That is cool. That is cool. And at the end, I would like to print nothing. My offer is this, nothing. Let's see. I have to wait 5 more minutes before I wait. Let me go to the washroom and refresh a bit, and then I will come back in like 2 to 3 minutes. I am back, and I at least feel maybe a little refreshed. But do I actually need to feel refreshed after just coding for 2.5 hours? There is not much time. And yes, so my answer was wrong. Let's get serious now. 2568. I cannot mess up now. I know that 2568 and 2567 are wrong. And I can start submitting from 0 and go till 3000. No, no, this is good. So I can remove this, and this will go up to Si is not equal to not null, right? Right. And here also, remove this motherfucker. And even here, remove this. Compile and run. 2566. That is the closest. That might be actually correct. That might actually be correct. That might actually be correct. 2566. 2566. But I have to wait for some time. 2566. I have to wait for some time. Yep, I have to wait 1 minute and 16 seconds. What do we do in 1 minute and 16 seconds? We can do some quizzes. Yep. Yo, we got this. We can do capital games, capitals of the world, capital of the world. Yep, hard level 3. Let's go. Uh, Bangkok. Bangkok is the capital of Thailand. Yerevan. Yerevan is the capital of this thing. Armenia. And Islamabad is the capital of Pakistan. Nassau is the capital of Jamaica. Right? No, not Jamaica, but Bahamas. Stockholm, uh, Switzerland, Naypyidaw, Myanmar, Djibouti, of course. Accra, yes, Accra is the capital of Ghana. Yes, fucking hell. Gaborone, Botswana, South Tome. One of these is Sao Tome. Yep, Sao Tome. Ljubljana, Slovakia, right here. And Seoul, South Korea. Bucharest, Romania. Yaoundé, Cameroon. Go. Wellington. Shit. New Zealand? New Zealand. Fuck. Bangui is Central African Republic. Central African Republic. Delhi is East Timor. Brazzaville, Republic of Congo. That I do not know. I have not studied that, but that is probably in Africa. I would go with Tanzania, Togo, not Sudan, but not in Chad. This, not any one of these. It could be this. Madagascar. Okay, Brussels. Belgium. Below that, Porto Novo, Benin. Let's go Riyadh, Saudi Arabia. Honiari. Honiari. No idea. Honiari. Honiara. No idea. One of these. Oh, those islands. Pyongyang, North Korea. Manila, Philippines. Maputo. No idea. One of these, I don't know. I am learning still. Mozambique. Okay. Cairo, Egypt. Jakarta, Indonesia. Ulaanbaatar. Vientiane, Laos. And that was okay. And now we will see 25666, right? 2566. 2566, that is not the correct answer. You are using the full input data. I am using the full input data, right? At the end, I have V and then forward character, V and forward character. I am using the full input data, but still I am fucking up somewhere. What the heck, what the heck, what the heck, what the heck? I actually thought that I got it this time. 2566 is wrong. Okay, let's see what I am doing. I am taking in this till this line, this whole thing is creating a buffer which contains the content of that file, right? Right, which contains the content of that file. I can print it and verify like so. What's this out? Yes, I have printed it and verified it, and strangely enough, I have new line character at the end. Why do I have a new line character at the end even though I do not have that? I did not add that here. So can I, instead of checking for this, can I check for new line? Will the answer be different? 2565. Okay, are you going with that? Okay, I will be going with that. 2565. That is what I'm going to go with. And I don't think that there is any problem with the code. shit, I cannot risk it. It might tell me to wait for 15 minutes the next time I submit a wrong answer. So, yep, 2 5. Let me examine the code again. Yep. This part is giving me a buffer which contains the input file. Okay, and then I call give unique houses function on that buffer and I print the answer and then I free the buffer and close the file. So what the heck does give unique houses function do? It takes a character array, start at index 0, declares a maximum. Oh, fucking hell. What am I returning? At the end, I am returning the index, right? Which is correct. Now it's connected. Now I can actually. Yep, it seems to be connected. And. Shit, my screen is stuck. The heck is happening? Phone got stuck. Oh, at least the phone's camera was working up until now. Now it stopped. No, 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 no. Do not disconnect. And now it did actually stop. Yo. Yep, the camera is working, but screen is not. Let me add the screen capture again. Yep, okay, and transform to fit to screen. Bring this down, and it has already gone on for too long. I do not want to risk it. Yes, and do I want to check for other characters? When for si is not equal to this and si not equal to null character. Why am I checking for null character? Because I want to pass in custom strings. I want to pass in custom strings like up, down, up, down, up, down, up, down. This should give me 2. But if I do right, up, left, left, down, down, this should give me what? I don't know. This should give me about 1, 2, 3, 4, 5, 6, 6 as the answer. But does it? Does we split text.txt and let me see v. Here I have v and I yank that, and if I copy that v here, and after that if I copy my v, yes, both the v's are similar, so that should not be causing any problem. Let me move this to the right, move this to the right. Yep, just like that. That is just too much into the right, so let me do yep. Am I going with that with the new answer? Okay. New input, puzzle input. I will update it and yep. Clang ./out 2565. Is my screen working? Yes, my screen working, camera working, screen working, everything is working except the code. 2565. Fucking hell. Fucking hell. 2565. Is that correct? Let me see. Is anyone watching? Does anyone know the answer? No. No one's watching. Of course. Yes. 2565. That is what I'm going with. 2565. 2565. 2565. Okay. Okay. We did that. That will be the end of the stream. Well, at least we can. What the second is? 20. The next two speakers to the present. And I simply present two same based from the is going to be reading from the same script as the previous year. This year, how many houses receive at least one present? For example, this delivers presents to three houses because Santa goes north and then Robo Santa goes south. This now delivers presents to three houses. Santa and Robo Santa end up back at where they started. This to 11 houses. I think we got this. If we build upon the code we did in part 1, we got this. Part 2.c, we got this. Right, right. So I have to declare memo 1 and memo 1, memo 1, and also memo 2, memo 2. Two memories for row center and the normal center, and not 1 and 2. It sounds robotic. Memo S for center. S memo shit. Memo S and memo R for robot. R for robot. Current. Okay, I want to have current S and current capital R. Current position for the robo and current position for the Santa, and based on if I is even or odd, I will be checking for different things. Okay, that is correct, and I will be having this, and yes, index will be different for both of them. Index will be index S and index R, index S, index S, index R, index R. Okay, now change in here. Okay, for the current thing, I will get the direction as same, and then yes, now I have two conditions. If I is a remainder with 2 equals 0, then I have to do something. Then else I do something equals 0. If it is 0, then that is, let's say, Santa, and if it is one, then it is Robo Santa. Copy all of this, align it like that, and put all of this That is, if it is 0, that is even. Then Santa would move. Otherwise, robo Santa. Current S, current S, and memo S, right? And index also S, right, right. This is also S. 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 This becomes S. This becomes S. This becomes S. Capital S. And otherwise, yep, this has to do with S only. No, direction is just direction. No change there. And this becomes a robo for robo Santa. And this also becomes R. And this also becomes R, right? Yep, but index also becomes R for rows and that. Go back, make this R, make this R. No, direction is just direction. No change in direction. Uh, change to index, change to index, and yep. Yeah, yeah. Is that correct? Wait, my wait, let me stream 3 remove video capture device. Go back here. Yep. What will I get? I will get unique visits. Unique visits is getting updated every time, and yeah. Yes, I am not seeing any errors. This should work. Should this? Yep. Clang part 2 should be output to dot out dot slash out 2837. That does not seem like the right answer somehow. Let me use my own input. Would be 1, 2, 3. This should return 3. Let me do this for a couple of things, for a couple of numbers. I'll print this, then unique visits equals give unique houses for what? For this thing, and print it, and unique visits for equals give unique houses for this. All right. What do I expect to see? I expect to see 3, 3, 11, 3 to 10. Okay. Well, that means I can find out what the heck is wrong. 3 to 11. Why is it 3 to 11? First one is correct, it is 3. Second one is wrong. Second one makes a whole circle thing. But why is it 2? This starts from 0. First one goes in here, second one goes somewhere else, and third one here. Let me print a memo for both of them. Print memo memory S will be the first one printed. Okay, we'll keep that in mind. Too few arguments. Okay, index S, yeah, and here I will print. No, what the heck? Here I will print memo R index R. Fuck. And after the second one, I want to print F a a couple of new lines. Let's say, and let's see Clang part 2. Okay, what do I see for the for this? The first one goes up and down and up and down. This one goes up one step and the second one goes down one step. That is cool. In the second one, the first one does not go anywhere. Wait a minute. Okay, yes. The first one does not go anywhere. Why the fuck did it not go, and why is it being printed like 4 times? Four, four, four. Why is it printed 4 times? Till the string is not equal to n. Haha. That should not be causing any problem. The problem is in here somewhere. Okay, I will be printing both of them. First the Santa one, and then this one, and this after everyone. And also, if number, I'll be printing I. That is cool to be able to see that. And now yes, for I0, the Santa went up one step, and for I1, the robot went down one step. For I0, Santa didn't move, robot didn't move. Why? Why did they not move? Should have. In you, unique visits. Let me replace this with this and see, is it happening because of well, order changed and the answer changed. That is just crazy. I'm getting the right answer for the first one, 2 for the second one, and why am I getting the wrong answer like that? If I replace this with this, so I get the correct answer for the first one. That is 11. Yes, I do get 11. I guess I can trust it for the first time that I'm calling it. But I actually do want to know why is it not printing it correctly for the first time itself. But shit, it will start printing all the things that I do not want it to print. Line dot slash out. Answer is 2837. According to this, the answer is 2837. 2837. Is that correct? 2837. Yes, 2837. Okay. Hmm. Answer seems to be too high. Why is it too high? I goes from here till the end. I get the direction first of all, and I have declared separate memory and separate memory and separate index for both the robots, for both Santa and the robot. They both start at 1 and both increase. They both start at 0 and then are increased to 1 when I add the elements. And I also have two cursors. One cursor for the Santa and one for the robot. And here I am. Okay, I'm getting the direction. That is cool. That is truthful. That is what anyone should do. After getting the direction, I am seeing if it is even or odd. If the roles for Santa were switched, then it would not make any difference, would it? Nope, it would not. If I do I equals 1, then I should get the same answer. 2837. That is 2837. Part 2. Yeah, I can give my time and understand why this is being wrong. But tomorrow. Like, it was hectic. We did this. Tomorrow we will continue with part 2.